Can meditation really slow aging? This is the article I saw on CNN. It's 7 in the morning on the beach in Santa Monica, California. The low sun glints off the waves and the clouds are still golden from the dawn. The view stretches over thousands of miles of Pacific Ocean. In the distance, white villas of wealthy Los Angeles residents dot the Hollywood Hills. Here by the shore, curlews and sandpipers cluster on the damp sand, a few meters back from the water's edge. A handful of people sit cross-legged, members of a local Buddhist center, about to begin an hour-long silent meditation. Such spiritual practices may seem a world away from biomedical research, with its focus on molecular processes and repeatable results. Yet, yet just up the coast at the University of California, San Francisco, UCSF, a team led by a Nobel Prize-winning biochemist is charging into territory where few mainstream scientists would dare to tread. Whereas Western biomedicine has traditionally shunned the study of personal experiences and emotion in relation to physical health, these scientists are placing state of mind at the center of their work. They are engaged in serious studies, hinting that meditation might, as Eastern tradition has long claimed, slow aging and lengthen life. The Nobel Prize. Elizabeth Blackburn has always been fascinated by how life works. Born in 1948, she grew up by the sea in a remote town in Tasmania, Australia, collecting ants from her garden and jellyfish from the beach. When she began her scientific career, she moved on to dissecting living systems, molecule by molecule. She was drawn to biochemistry, she said, because it offered a thorough and precise understanding in the form of deep knowledge of the smallest possible subunit of a process. Working with biologist Joe Gale at Yale in the 1970s, Blackburn sequenced the chromosome tips of a single freshwater creature called Tetrahymena, Ponscum as she described it, and discovered a repeating DNA motif that acts as a protective cap. The cap, dubbed telomeres, were subsequently found on human chromosomes too. They shield the ends of our chromosome each time our cells divide and the DNA is copied, but they wear down with division. In the 1980s, working with graduate student Carl Greiger at the University of California, Berkeley, Blackburn discovered an enzyme called telomerase that can protect and rebuild telomeres. Even so, our telomeres dwindle over time, and when they get too short, our cells start to malfunction and lose their ability to divide, a phenomenon that is now recognized as a key process in aging. This work ultimately won Blackburn the 2009 Nobel Prize in Physiology or Medicine. In 2000, she received a visit that changed the course of her research. The caller was Elisa Appel, a postdoc from USCF Psychiatry Department. Psychiatrists and biochemists don't usually have much to talk about, but Appel was interested in the damage done to the body by chronic stress, and she had a radical proposal. Appel, now a director of the Aging, Metabolism and Emotion Center at UCSF, has a long-standing interest in how the mind and body relate. She cites as influence both the holistic health guru Deepak Chopra and the pioneering biochemist Hans Selye, who first described in the 1930s how rats subject to long-term stress become chronically ill. Every stress leaves an indelible scar. An organism pays for its survival after a stressful situation by becoming a little older, Selye said. Back in 2000, Appel wanted to find that scar. I was interested in the idea that if we look deep within ourselves, we might be able to measure the wear and tear of stress and daily life, she said. After reading about Blackburn's work on aging, she wondered if telomeres might fit the bill. With some trepidation, at approaching such senior scientists. The then postdoc asked Blackburn for help with a study of mothers going through one of the most stressful situations that she might think of, caring for a chronically ill child. Eppel's plan was to ask the women how stressed they felt, then look for a relation between their state of mind and state of their telomeres. Collaborators at the University of Utah would measure telomere length, while Blackburn's team would measure levels of telomerase. Blackburn's research until this point had involved elegant, precisely controlled experiments in the lab. Eppel's work, on the other hand, was on real complicated people living real complicated lives. It was another world as far as I was concerned, says Blackburn. At first, it was doubtful that it would be possible to see any meaningful connection between stress and telomeres. Genes were seen as by far the most important factor determining telomere length, and the idea that it would be possible to measure environmental influences, let alone psychological ones, was highly controversial. But as a mother herself, Blackburn was drawn to the idea of studying the plight of these stressed women. I thought how interested, she said, you can't help but empathize. It took 4 years before they were finally ready to collect blood samples from 58 women. This was to be a small pilot study to give the highest chance of a meaningful result. The women in the two groups, stressed mothers and control, had to match as closely as possible, with similar ages, lifestyles, and background. Eppel recruited her subjects with meticulous care. Still, Blackburn says she saw the trial as nothing more than a feasibility exercise, right up until Eppel called her and said, "You won't believe it." The results were crystal clear. The more stressed the mothers were, the shorter their telomeres and the lower the level of telomerase. The most fragile women in the study had telomerase that translated into an extra decade or so of aging process to those who were less stressed. While the telomerase level were halved, I was thrilled, said Blackburn. She and Eppel has connected real lives and experiences to the molecular mechanics inside cells. It was the first indication that feeling stress, doesn't just damage our health, it literally ages us. Unexpected discoveries naturally met skepticism. Blackburn and Eppel struggled initially to publish their boundary-crossing paper. Science, one of the world's leading scientific journal, couldn't bounce it back fast enough, chuckles Blackburn. When the paper finally was published in the Proceeding of the National Academy of Science in December 2004, it sparked widespread press coverage as well as praise. Robert Sapolsky, a pioneering stress researcher at Stanford University and author of best-selling Why Zebras Don't Get Ulcers, described the collaboration as a leap across a vast interdisciplinary canon. Mike Irwin, director of the Cousins Centers for Physioneuroimmunology at the University of California, Los Angeles, says it took a lot of courage for Eppel to seek out Blackburn, and a lot of courage for Liz Blackburn to say yes. Many telomere researchers are weary at first. They pointed out that the study was small and questioned the accuracy of the telomere length test used. This was a risky idea back then, and in some people's eyes unlikely, explained Eppel. Everyone is born with very different telomere length, and to think that we can measure some psychological or behavioral, not genetic, and have that predict the length of our telomeres, this is not really where this field was 10 years ago. The paper triggered an explosion of research. Researchers have since linked perceived stress to shorter telomeres in healthy women, as well as in Alzheimer's caregivers, victims of domestic abuse and early life trauma, and people with major depression and post-traumatic stress disorder. 10 years on, there is no question in my mind that the environment has some consequence on telomere length, said Mary Aminos, a a clinician and genetic at Johns Hopkins School of Medicine who studies the telomere disorder. So this is an article that I saw on CNN, and it has to do with does stress has anything to do with the aging process. Thanks.